want to have some fun, playing games, watch TV, something like that. But you may consume nothing. So this point would be your endowment. Some people translate it as 原付点 or 禀赋点. Initial endowment. But if you got some transfer Y star from someone who cares about you, then your endowment could be here. And the height would be Y star. So either by here or by this point, if you want some more money, you have to go to labor market to earn it. You got to work. And if you work all day, 24 hours, you use 24 hours to work, then this intercept would be 24 times W. Alright? Because per hour, you may earn W. It's the hourly wage rate. So if you spend all your leisure time to work, so at this point, you have no leisure time, but you may have 24 times W. Or if your endowment, if there is someone giving you some money, Y star, then you may have 24W plus Y star. Okay? So this is 24W plus 0. 24W plus Y star. It depends on whether you have some sources that people would give you money. Okay? And what about the slope for the budget line? The slope would be negative W, right? Because per hour you spend in working, you may earn W. So the slope would be W over 1, which is W, with a negative sign. So on the diagram, of course, if you see your endowment point at this one, which means there's no transfer from others at all, right? And this would be your budget line. Given this budget line, this is the indifference curve, because leisure time is good and consumption is another good. Leisure time and consumption, both good satisfies what? Both good satisfy the property that the more the better. Okay? So you may regard leisure time as good one and consumption as good two. So it's an indifference curve. But with a limit here, because for all of us, we have at most 24 hours a day. So we may not consume, or this part is not regarded as available. So initially, you may choose E1 as the optimal choice. So what does E1 mean? E1 means you have 16 hours as your leisure time, and you spend 8 hours because 24 minus 16. So 8 hours to work, and you earn Y1. Y1 equals 8W. Okay, 8W. So your consumption would be Y1, and your leisure time would be 16. 16 hours. And how do you interpret a steeper budget line? How do you interpret this? With a steeper budget line, which means the slope, the absolute value of the slope becomes larger, right? Which means you got a higher wage rate. So if you got some higher wage rate, W2. So W2 is higher than W1. Okay? So with a higher wage rate, you may choose this point as your optimal. And for this one, your leisure time would be 12 hours, and you spend 12 hours on working. And you earn Y2. Y2 equals 12W2. Okay, 12W2. So with an increase, in wage rate, your working hour increases. And the reason why your working hour increases is because, okay, the pure substitution effect would be here, right? Is that right? And new W2, and with the original utility level, so this would be where you choose, right? So it's the pure substitution effect and income effect. So from here to here, you will see both consumption or leisure hours are normal good. Okay? All right? So this is the price effect. And the pure substitution effect makes working hours higher, but this would be with the substitution effect. And for the income effect, because leisure time, if leisure time is a normal good, then H become less, right? With an increase in your wage rate, which means you become richer, right? Your real salary or your real income is higher. So you see a conflict for these two effects, substitution effect, income effect. Even or given N is normal. You should remember something that given this model, if P1, for example, P1 decreases, and for the substitution effect, you will increase your consumption in Q1, right? And for the income effect, if Q1 is normal, you will consume further, even more, Q1. So the direction for a normal good, if Q1 is normal, then you will see with a reduction of P1, with a drop in P1, your consumption on commodity 1 would increase, by the pure substitution effect and by the income effect. They will go in the same direction. However, if leisure time is normal, with an increase in wage rates, an increased working hour, which means a decreased leisure time for pure substitution effect. However, for income effect, your leisure time will be higher. So there is a conflict in this model. And the reason here is because the endowment is at the horizontal intercept. However, for this model, your endowment is on vertical intercept. Is that clear? In this labor supply model, your initial endowment is at this point. But for the normal indifference curve model, your initial endowment would be on vertical intercept, because this would be y over p2. And now the variable which changes is p1. We hold y, income, and p2 unchanged, right? So you see the difference here? The rotation with this as the pivot, but the rotation here use this intercept as the pivot. Okay? Yeah. Mathematical analysis, we use calculus to find tangency point between indifference curves and budget line. So we may rewrite the model as this. Y equals WH. Actually, you may plus Y star here. And 24-hour minus H. And first order condition will be partial U, partial Y, and Y by H. So we differentiate, or we want to choose an optimal working hour level. So we differentiate the whole function with respect to H. So partial U, partial Y, and Y is actually a function of H. And also partial U, partial N, and N is actually another function of H. And the first part, the first term, partial U, partial Y, would be the marginal utility by Y. And how can we interpret this term, U, Y? One more money, or the extra or the additional utility we derive from one more dollar. And differentiate Y with respect to H. Y with respect to H would be the wage rate. Okay? And this is plus. And how come we have a negative sign here, a minus here? It's because the chain rule. So UN, and N over H. Differentiate N with H, because N equals 24 minus H. So the second term would be -1. That's the source of the minus sign. And this first order condition is actually, we may have a story behind this one. Okay, so one more hour to have fun, or one more leisure time, 1 more hour leisure time. We need to sacrifice W. And for each dollar, we may have this unit or this utility, this level of utility. And now we have sacrificed this much, or this amount of hourly wage. So the utility we sacrifice for 1 more hour leisure would be this term. Okay? So let's make an assumption. Assume the marginal utility for consumption or income. So this would be the marginal utility by $1. Let's assume that this value is the same with you and me, okay? However, your wage rate now at your age differs from mine, right? My hourly wage reasonably to be higher than yours. Can you accept this assumption? Actually, it's a fact, right? So, if we regard this as the opportunity for 1 more hour of leisure, whose opportunity cost is higher, yours or mine? This would be the opportunity cost, right? And let's assume this value is the same with you and me, but we have different wage rates. My wage rate is reasonably to be assumed higher, so my opportunity cost would be higher than yours, right? So if you want to buy something but with a long queue, with a long line, standing in the line costs you less. So you may be more willing to do that than me, right? So basically, I hate to get into a queue. It's about something about personality and something about my opportunity cost. I just don't want to get in a queue to waiting for buying something. All right. So don't forget that for 1 more hour of leisure time, this would be your opportunity cost. And the slope of MRT would be negative W. And MRS as usual. We say MRS equals U1 over U2. Now, 1 is the commodity on the horizontal axis and 2 is on the vertical. So, on the horizontal now is the leisure time. On the vertical is what? Y. Is that right? So, negative UN over UY. So, UN, if we move this term to the right hand side and divide by UY, which would be W. So this is the MRS and this would be MRT. MRT means the slope of the budget line. So for optimal choice, the tangent point MRS is the slope of the indifference curve, and MRT is the slope of what? The budget line. So at equilibrium point, this equation must be, or this condition must be satisfied, which comes from the first order condition, right? So this is the mathematical part. Yes? Yeah? That's the next part we are going to talk about. Okay, graphically, when wage rises, it's optimal to work more hours and decrease leisure. Okay, but sometimes, okay, this is what you are asking. Okay, and I will explain later, 2 slides later. Let's go back to here. So, okay, let's start from this. From this diagram, if now we make the vertical axis by W and this by N, so E1 with W1 as lower wage rate W1 with W2 a higher wage rate W2 with a lower wage rate or leisure time is 16 hours with a higher wage rate or leisure time demanded would be 12 hours. Okay, so we may derive using this approach as what we did before. We may derive the demand for leisure. So W is actually the cost of leisure, right? The price for leisure. If you want to have 1 more hour for leisure, you will, or you have to give up 1 more, you have to give up W. W is the hourly wage. So suppose your hourly wage to be, say, like $300. Then if you want to spend 1 more hour with your friends, you want to go to KTV with Lao Wang, 1 more hour, you got to give up your $300 salary, right? Because it's the hourly wage. So W, wage rate, is actually the price for your leisure. When the price is higher, you consume less leisure. When the price is lower, you consume more leisure. Alright? So this would be a normal demand curve for leisure. But if still we change the variable on the horizontal axis to H instead of N, and W1 W2. So 16 hours for leisure, which means 8 hours for working hours, right? 8 hours for working. 12 hours for leisure, which means 12 hours for working. So when the price is lower, your working hours will be less, 8 hours. And you work more to 12 hours if your wage rate increased to W2. So this would be your supply of labor. Demand for leisure, supply of labor would be actually like a twin. Oops. So the supply curve for hours worked is the mirror image of the demand curve for leisure hours. Okay, so this is the demand for leisure, supply of working hours. And this is how we derive the labor supply curve. Alright? Labor supply curve is actually the mirror of leisure demand curve. Because working hour here is assumed to be opposed to leisure time. Is that clear for you? So here, in this model, we just make an assumption that for each of us, we have 24 hours per day. And we divide this 24 hours into two parts. One for leisure and the other for work. Okay? So leisure time is opposed to working hours. More leisure, less work. Less leisure, more work. Okay? So this is how, or this is why they are mirror to each other, mirror image. Alright, next one. Income and substitution effects. An increase in wage causes both income and substitution effects. So total effect of a wage increase is moved from E1 to E2. Is from E1 to E2. Okay, so from E1 to E2 is a price effect, total effect. However, substitution effect, this will be substitution effect from E1 to E star. From E1 to E star. So with an increase in wage rate, you consume leisure less, which means you work more. You work more. However, the income effect would be from E star to E2. Income effect from E star to E2. So income effect make you work less, but substitution effect make you work more. As I said, there is a conflict between these two effects, right? And the total effects depends on which effect dominates which. So which one is dominant effect? In this case, which do you think would be dominant? Substitution effect, income effect. So substitution effect is less, income effect is more, right? So in this case, you see income effects dominates. Okay, let's go back to previous diagram here. I want you to compare on your slide. For this, substitution effect and income effect. So on this diagram, on this slide, the substitution effect dominates the income effect, okay? So